Vibe coding is everywhere right now. And I quite understand the appeal, right? You describe what you want, the AI builds it, and you probably don't need to read the code. You do not understand the code, you just keep vibing until it looks like it works. Then you ship it to production. Here is an uncomfortable part of the conversation. For a weekend project, that is kind of fine. For software that is real, that people use, that people's lives depend on, vibe coding is a liability that is waiting to bite you in the backside. In the next few minutes, what I'm going to do is I'm going to explain to you and give you the framework that sits on the other side of vibe coding. How engineers, real engineers now, how they actually use AI coding tools with discipline, with accountability, with results that survive a code review and even survive in production. Trust me, okay? Because I use AI every day. This is not an anti-AI video. I use these tools every single day, from Claude Code to GitHub Copilot to OpenAI Codex. I use all of them every single day. This is about the difference between a tool that makes you faster and a habit that makes you fragile. Let me be precise, okay? Let me be pinpoint about what vibe coding actually means. Vibe coding is generating code you don't fully understand and you ship it anyways. The vibe matters more than the comprehension. You feel productive, yes, you're shipping to production fast enough, and you're moving very fast, and you're quietly accumulating risks that you cannot see. That is vibe coding. For hobby projects, for learning, for rapid prototypes, this is great, this is awesome. AI accelerates all of that. And I'm not going to pretend otherwise. For a quick demo, that is awesome. You probably it just works. You show it works. You don't need to go into this, and it's probably not going to ship to production. That is fine. The problem really starts when those habits work with you into the professional environment, into shared code bases, deployed services, into your code reviews, production systems that page someone at 3:30 in the morning when they break. Those, to be honest, they're a headache. And this is the line. On one side, there's speed with no consequence. On the other side, there's code that has to hold up under load, under attack, and under the next engineer who has to maintain it. Probably just an intern. So why does vibe coding break the moment it eats real engineering work? Let me give you the honest reasons, because I've seen it. I live in it every single day. The first reason is AI, whatever AI tool it is, trust me, it is confident even when it is wrong. It will write code for you that looks clean, reads well, and it's subtly broken where you probably cannot even see if you don't know what you're doing. The happy part works in your demo. Demo is awesome. The leadership is clapping for you. The edge case fails when you ship it and it's in the hands of your customers. That is the first reason. The second reason is that you cannot debug what you never understood anyways. When the AI wrote it, it worked. You did not read it. A production bug comes like a treasure hunt. And because you did not read the code, you don't understand it, you have no clue because it looks like a stranger wrote it. Because to be honest, a stranger wrote it, even though yes, you paid for it. The third reason is that code is read far more than it's written. Your teammates inherit what you ship. If you can't explain it, neither can they. That's the simple truth. The cost does not disappear. You're saving time, yes, but the cost does not disappear. It just moves down the calendar and lands on probably someone else who's probably gonna eat it for the rest of their careers. Vibe coding optimizes for the next 10 minutes. Yes, I'm all doing it. Engineering optimizes for the next 10 months and next 2 years. That is the whole tension in one sentence. And let me make this concrete for you, right? Because yes, a lot of my people, even sometimes I do vibe coding just to get a quick project out and all that. Picture a feature that took an afternoon to vibe code. The demo worked flawlessly. It ships on Friday, and on Monday morning, it started throwing errors under real traffic. And the person on the call did not write a single line of it. That is absolutely mind-boggles. Now, what they have to do is reverse engineer your code at speed with users watching. That afternoon, you saved time last week, and the following week, you're spending 2 days, 3 days debunking that code with the entire team, wasting every single person's time. Look, speed that creates cleanup is not speed. It is a big technical depth with a friendly face to it. So here's the framework, right? 3 principles that guide how you use AI for coding. 3 principles, and this is how serious engineers actually use AI tools every single day. The first principle is you own every single line of code AI generates for you. If the AI wrote it and you committed it, it is yours. It is not AI's fault. Full stop. You are responsible for what it does, why it works, and what happens when it fails. First principle of AI generated code. You own it. Now, this is not about reading every single character of code before you merge it. It is about being able to explain your code to a colleague without saying the words AI wrote that part, Copilot wrote that part, Claude wrote that part, Cursor wrote that part. That is irresponsibility at the very highest level of it. If you cannot explain it, you, my friend, you're not ready to ship it. Treat the AI output the way you would test a third-party library that you probably don't trust. You did not write the library either, but you still own every decision to depend on it. Same rule literally applies here. The second principle that guides your use of AI generated code is prompt with intent, not desperation. You want it to work and say, fix this, get that, this bug is causing problems. No. Vibe coding prompts generally sound like that. They sound like, make this work, fix this, just build me something. That is not a prompt. That is a wish waiting to bite you in the backside. Engineering prompts are pretty specific. They carry context, they carry constraints, and they carry a specific acceptance criteria. Here is a vibe prompt. Build me a login system. To be honest, seriously, as an engineer, listen to me, that is so vague. Here is the prompt that probably will make a bit of sense to you. I need an ASP.NET Core authentication endpoint that validates credentials against Azure AD2C, returns a JWT, and handles token refresh. Error responses follow our existing API format: 400 for invalid input, 401 for failed auth, and 500 for service errors. That is a prompt that you give. You give it a context, you give it a constraint, and you give it an acceptance criteria. When it gets to work, it actually writes code based on those. Same goal, login system, and that beautiful prompt, but with a completely different output. The engineering prompt gives you a model, what it needs to produce, something that you can actually review. The vibe prompt gives you something that might work, might not work, you might have to start reprompting every single time and burn tokens. And you have no way to tell which one. The quality of what comes out as a result of using AI to write code, and this applies also to infrastructure code, to be honest, not just .NET code and JavaScript code and all that. The quality is set by the quality that you put in, the quality of the command of the prompt that you put into the system. Tools like GitHub Copilot, Claude Code, OpenAI Codex, Cursor, they're powerful. But let me be clear, they are not mind readers. The third principle is that build review into the workflow. Do not bolt it on at the very last end of it. Review as it's written. Vibe coders review AI code just once. At the very end, when everything is written. When they are tired and sleepy, the day is over and they just want to push and go home and end the day. This is the worst possible moment to catch a subtle bug in any kind of code, to be honest. Review early. Review in stages. After generation, before you touch it. After modification, before you commit. That is when you review what AI has written for you. At the generation stage, you're checking for correctness, obvious mistakes, and anything that looks unfamiliar and out of place. According to your principles, you know the engineering principles of your company anyways and what the industry accepts. Before the commit, you're checking the other things, security implications of what the code that has been written, error handling that actually covers failure cases, edge cases even, how it integrates with the code that already exists. Because to be honest, trust me, when AI writes some code, it actually breaks what works already and you have to spend days debugging it with AI again. 2 reviews, both shots together, they catch what one tired late review always misses. This is where AI coding discipline matters most. Guardrails. There are places you never, ever, for the sake of everything you hold dear and nice, ever vibe code. Okay? Authentication and authorization. Do not vibe code security into your application. AI models make subtle, dangerous mistakes in authentication code, JWT validation, scope checking, token refresh logic. Review every line out loud if you have to. Rubber duck it, peer review it even before you commit it. You must get that part right. To be honest, if you don't, you're just gonna mess things up. Data access and queries. AI generated queries can pass every API test when it's running on your machine, and they fail over at scale. I have seen this in production. We ship code, we ship versions, and then in production everything just falls flat. Yeah, we vibe review it again and we vibe push it, and it just still does not work. Why? Because AI wrote the query for you. Review that query. Hunt for the N+1 patterns that look harmless in development and melt your database in production and cause bugs and delays for your users, because that is where it's gonna matter the most. Undo the errors. This is the big one. Vibe coding produces a happy path for you to ensure code is fast and good to go out, but production lives and dies in these error cases that you probably miss. Review explicitly for what happens when network drops, the input is garbage and the dependency is down. How does your app perform in that time? Look for those things. Those are part of the things you put in your prompting and guardrail systems. And one more thing, concurrency and shared states. AI is reliably weak here. It fails successfully. Rest conditions, locking, anything touching thread or async ordering, the code compiles. It passes a quick test, but multiple users, concurrency, how does he handle it? Okay? And when this happens, corrupts data all at once, and then this is the worst kind of bug. Okay? Rare enough to ship, yes. Common enough to audit every single bit your code touches. Read the code like your reputation depends on it, because to be honest, it really does depend on it, because when audit comes, it's gonna come and bite you in the backside. If you only take one rule from this entire video, take this one. The places that are boring to test are the places that halt the most in production. Slow down there. Don't just vibe it. Slow down. Take your time with it. Hey, I'm telling you this because yes, business is gonna say, yeah, we need to ship this fast and all that, and you vibe it and it goes out. It's still gonna be a reputation when things break in production. It's gonna come back to you, to your team. Let me be fair, because this is not all caution, right? There are places where these tools are a gift and they are absolute delight. Disciplines engineers leaning hard on these aspects, and I'm gonna tell you, right? Boilerplate code, scaffolding, repetitive structure, that stuff is tedious and low risk. Let AI shine there. The platform is there already, the guardrails are there, the principles and the ways of working are there already. Let AI shine there. And when you're doing refactoring, when you have a clear target on how you're refactoring, writing the first draft tests, translating between languages, explaining an unfamiliar code base to you so you ramp up faster, generating documentation. These are the real ones for AI every single day. And I'm going to tell you for a fact because I have seen it at work. And exploring your code. When you're stuck, you don't know what line something broke on, you don't know what line to put your next piece of idea in. AI can excellently explore your code and tell you that. Ask it for 3 approaches. Argue with it. Use it to find the question and not just the answer. All right? And the real example from my own weeks is that I needed a data export feature in a code base, and the shape of it was obvious, right? Just tedious. I described the structure of the data I want to export, the format of it, the edge case I cared about the most, and the AI gave me a clean first pass in plan mode in seconds. I read it, fixed the small things, and moved on. That is the dream. Low stakes, high speed, fully understood. Compare that to authentication code, where I slow right down and treat every suggestion as a proposal and not an answer. I query every single decision the AI is making. I put it in plan mode first. Plan every single step. Plan every edge case. Once there's a clear path to writing the code, then go do it. The pattern is simple. Low risk and repetitive. Let it run. High risk and load bearing. Slow down and own it. That is the principle. That single instinct separates a productive engineer from a fragile one. And for me, Here is the exact loop I run every day. 5 steps: intent, generate, read, integrate, and verify. Those are my 5 steps I run to use AI tools every single day. Before I ask AI for anything and everything, write one line intent statement. This is what I want to achieve. Not for the model, but for me. I need this, I need X because of Y. And this is the constraint Z. If I cannot write that sentence, I'm not ready to prompt. I'm not just gonna say, oh, fix this bug for me. Fix this bug for me because it is causing this, but do not touch this. A practical example for a DevOps engineer, because I've been talking about .NET all along, is so a very plain, easy example I can say is, oh, you're trying to bring code, import a code from one Terraform Codebase into another and say, this was done in this project this way. I need it here because we are doing A, B, C, D. Learn the model of how the Terraform code in this code base was written, import it here, but in this code base, we do X, Y, Z, and this is how it applies. If I cannot say that in my day-to-day job, I am not ready to use AI. I might as well just go manually do it or resign. The thing is this, AI will generate your code. Then I read the output before it ever touches my editor. I don't skim through it, I read every single one of them. I'm checking for obvious issues, unfamiliar patterns, and anything that drifts from my intent, because I've written that intent down, what I want to achieve and why I want to achieve it. So if it drifts from that, I need to reprompt it. After I verify that, I then integrate into the code base, then I verify, I run it over and over again and ensure that whatever code it's connected to also are not broken. I look at the actual behavior of that code, not just whether it's compiled or did a successful Terraform plan. Compiling is not the same thing as correct. That loop for me takes minutes. It's the difference between the code that you trust and the code that you're quietly open, nobody asks you about. And for you, let me tell you what really changes when you actually live with the discipline. Your code reveals the change. You walk in confident because you understand what your AI wrote, or what you wrote in this case, then because it's in your name. No flinching when someone asks you why the code is doing that. Your debugging process changes when something breaks. You know where to look because you actually followed through every single step. Because you were there when it was built, you became the subject matter expert where AI wrote the code. And your confidence really changes in this way because you stop feeling like you're getting away with something. You are not taking a shortcut, you're using a tool to achieve a specific goal which you are confident and proud about. That, my friend, is the real difference. Because to be honest, shortcuts will leave you exposed. I've packaged this entire video, this approach, in a one guide document that is on my website. I'll give you the link in the video description because the intent is this, right? The review checklist, blah, 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 blah. I've packaged this entire approach in one guide. The full agentic coding workflow, the intent templates, the review checklist, the prompt patterns that I use with Copilot, Claude, and Codex every single day. Comment the workflow if you're watching this on any other platform, and I'll send you the guide, or just check the video description and pin comment for the link to that guideline for you. And I want to hear from you really as an engineer. Drop a comment and tell me where this line sits for you between vibe coding and disciplined use of AI in writing code every single day. And I think this conversation is actually really more nuanced than the internet makes it to be. Everyone vibes code, but should we? I'll see you in the next one. Bye bye.